All right, so chapter 2, we have summarizing data in tables and graphs. What does that mean? It means that now that we know what data is, and now that we know the experiment and the observational study that we're going to do, once we get all our data, how the heck do we start to organize it? So 2 is going to show us how to do it visually. Tables, graphs, charts. Chapter 3 will show us how to organize and summarize numerically. So we actually don't really do any math until chapter 3. Do any of you guys actually like math? Raise your hands, a couple of. For most of my course info sheets, there was a handful of you guys that admitted that math's not that bad and it's your favorite subject, and I rarely get that, so I'm kind of excited about that. So chapter 3 is when we'll actually get into computing, like real statistics, all right? But until then, we're going to do it graphically. So section 2.1 is organizing qualitative data. Do we remember what qualitative data is? A characteristic or a category, right? It's not numerical. And so objective one way we can do it is just with the table, all right? So you guys have done tables before. You've counted and you've tallied. The only difference in this class is that we're going to just call it something fancy, all right? So a frequency distribution lists each of your categories of data that you collected, and then it has another column that lists the number of occurrences that each of those categories happen, all right? Frequency means how frequent, right? So like if I asked you all your favorite color, my one side of my chart would be red, orange, yellow, green, blue, purple, teal, or whatever, you know. And the other side, I'd say, okay, how many people like red? How many people like orange? And go through the tallies, all right? So I give you an example here. It said a class's set of exam scores out of 100 points are listed below. Based on a normal 10-point grading scale, construct a frequency distribution of the data. Even though this data is technically quantitative, right? They gave us numbers. We will only think of it in a qualitative or a letter grade sense for this example, all right? So we are going to actually make it qualitative by, instead of looking at the points they scored, what letter grade they scored, all right? So what we're going to do is a normal grading scale. 90 to 100 is going to be an A, 80 to 89 is a B, and so forth. So when we make a frequency distribution, we literally count and see how frequently these occur, all right? So an A was 90 to 100, so how many times does 90 show up? 1, 2. And you know what's nice about pencil and paper stuff, which is not what you get on my math lab? You can kind of cross them out as you count them, right? Does that look okay, guys? Do you guys agree that there were 3 test scores that scored an A? So I'll just put a 3 over here. B is 80 to 89. 1, 2, 3, 4, 5. Does that look right? So we'll put 5 over next to B. C is anything in the 70s. 1, 2, 3, 4, 5, 6, 7. Does that look okay? D is going to be anything in the 60s. We're kind of process of elimination. 1, 2. And then F, is there only one F, that 55? Is that okay, guys? So it's nothing that we haven't done before. They're just giving it a new title. It's called a frequency distribution. Why? Because it tells you how frequently a qualitative data variable occurs. All right. So when you look at that, what can it tell you? Well, you can say most students got what on this exam? A C. Okay? So it does tell you information. But number sense, a lot of times instead of looking at it holistically with numbers, we like to look at it as a percent, like what percent of those students got C's. And we can't look at that and just know off the top of our head. So that's where a relative frequency comes into play. The relative frequency is the proportion or percent of observations within a category, and it's found using the formula, okay? So how do we find our relative frequency? The sum, how many total you have, is always the bottom. Remember, the N is your sample size. And this will be a common theme throughout the semester, guys. Whenever you're trying to find a percent or a fraction, how many total things you have is the denominator, all right? And then the top is the frequency of that category you care about, okay? So we're going to care about A, B, C, D, F, so we're going to take their individual frequencies and put them on top. So this is the individual amount. And what we're going to do is once we find all the relative frequencies, we'll be able to make a relative frequency distribution. And all that is the categories we're studying, and now the relative frequencies are part of our distribution. All right? So we're going to just use the same data as above. Oopsie, I'm like really, anybody getting seasick there? All right. So what we have here is A, B, C, D, F. I'm just going to steal our frequencies up from above. So we have 3, 5, 7, 2, 1. I'm not changing anything there. I'm just kind of putting it all in the same spot. So the first thing we needed to do is ask ourselves, well, how many total people were in this class? 18. And all you need to do is sum that, right? So n equals 18. Ooh, I'm going to make it. N equals 18. So what does that mean? That means that's going to be our denominator for every single one of these frequencies, okay? I'm going to show the first couple operations, but you guys, once you know what you're doing, you can kind of just go right to the decimal. My math lab will tell you what to round to. For some reason in my notes, I'm not very good at telling you. So let's just round to 2 decimal places, all right? So this is 3 out of 18. Why? Because there's 18 students and 3 of them got an A. You throw that in your calculator, and I believe you get 0.16 repeating, okay? So if we're going to round to 2 decimal places, that's just going to be 0.17. Or if you want to think of it as 17% or 16.6% repeating, that's fine. Typically, we leave relative frequencies as decimals between 0 and 1. All right, B, how are we going to do B? The exact same way, but what's the frequency for B's? 5. So we're going to do 5 out of 18. Throw that in your calculator, and I believe you get 0.27 repeating, okay? But that 7 will make the 7 round to an 8, so that's 0.28. Does everybody see where these numbers are coming from? Is that okay? All right, so 7 out of 18. Throw that in your calculator, you get is that 0.38 repeating, I think? So that's going to round to 0.39. 2 over 18, throw that in your calculator, you get 0.1 repeating, so that's going to stay 0.11. And then 1 out of 18 is 0.05 repeating maybe, okay? So that's going to round to 0.06. All right? Typically in a distribution guide, you're not going to show your work like this, but since it's the first time you're seeing it, I'm going to show you how we got it. The distribution will look like this. Your qualitative categories, the frequencies of each, and the relative frequencies of each, okay? Why is that important? Because now, can't you guys still see the majority of students got what? A C, but you can tell me a little bit more. You can tell me 39% of the students got C's, where before you said it was just the highest number, so the most scored a C. So people do a little bit better because it's all relative. It means you can compare from one to the next, and so you have an idea. We rounded quite a bit, but typically when you do relative frequencies, if you sum all of these, since it's 100% of your data, these should sum to 1 or something close to it. We rounded up a lot though, so this is probably sums to a little something over 1. Did anybody do that? 1.01. 1.01. So we were pretty close then, okay? So you'll be a little bit over, you might be a little under, like at 0.99, just because of rounding rules. I cannot stress enough, guys, pay attention to what my math lab wants you to round to. But under every little answer spot in like a navy blue purple font, they'll say round to the nearest thousands, round to the nearest hundreds, that kind of thing. On a homework, I'll have you do it over again, but on a quiz, if you accidentally rounded to like 0.166, just send me a message and say, hey, I don't want to take this quiz over again just because I rounded inaccurately, and I usually give you your credit, okay? Just let me know, though, because I have lots of quizzes floating around with 3 attempts each and so forth. So I usually don't go like stalk each of you, but if you just keep track of your own quiz and let me know, I'd be more than happy to give you that credit before you have to take it all over again, all right? So we're still kind of numerically summarizing, and so the whole point of chapter 2 is, hey, not everybody likes numbers. Not everybody gets something from these numbers. So what we can do is we can take both our frequency and relative frequencies and change them to bar graphs, all right? So if you look at the very last definition, guys, a bar graph is exactly what we know a bar graph to be, okay? It's constructed by labeling each category of data on a horizontal axis, so that's your qualitative data that you collected, and the frequency or relative frequency of the category on your vertical axis. Rectangles of equal width are drawn for each category, and the height of each rectangle is equivalent to that category's frequency or relative frequency. One thing I want to note, can be horizontal as well. This can be horizontal too. So they're strictly saying, it's kind of like what Spencer was talking about. Remember how you mentioned like independent, dependent variable? They're flat out saying that you have to put it on the x-axis and then you have to put the frequency on the y-axis. It doesn't have to be that way. It can be flip-flopped, okay? As long as you just label your axes and draw your bars appropriately, that's fine, all right? So let's look at these two that we have going on this. So here's an example I just stole from the book so you didn't have to try to see me draw a frequency distribution. This is a frequency distribution based on what injuries people have when they go in for rehab, okay? So notice that the qualitative data that they recorded were the types of injuries, and so here's the body part, and notice they labeled the axis body part, and they labeled each of the individual data values. But then on the right-hand side, it's literally just frequency, and they drew the bars appropriately. So I can ask you guys, how many people go in for rehab that have shoulder injuries? 4. You see how that happens? How many have hand injuries? 2. That kind of idea. So the whole point is the bar is drawn to those numbers that we came up with. So if we had to, we could draw a bar graph equivalent to those A, B, C, D, Fs that we did on the front page. Is that okay? The only the only difference between a frequency bar graph and a relative frequency bar graph, I ask you right here. This is why I don't have 2 pictures of it, because they're basically the same. What would be the only difference about this bar graph if we used relative frequencies?
The y-axis.
The y-axis, right? Instead of labeling the nice whole numbers 0 to 12, what would our y-axis be labeled with? The decimals, 0.0 all the way to 1, right? So the difference would be that the y-axis, or the vertical axis, right? The vertical axis would be decimals from 0 to 1. You guys see that okay? So again, think of that data that we just did on the front page. We would just, instead of going up to 7 or whatever for C's, we'd go up to 0.39, all right? So you would just have 0 to 1, and you might go 0.2, 0.4, 0.6, 0.8, you know, that kind of idea. And we'll get plenty of examples with that. And that's the only difference. So that's kind of why I don't waste space showing you 2 different types, okay? And actually, I think it's in your book, so I can even show you. That's what I remembered to bring today. My book. What page are you on, Missy?
63.
So 63 actually shows this exact same graph, but as a relative frequency distribution. Don't the actual charts look exactly the same, like the heights of the bars? You guys see that? What's the only difference? Instead of going up 0 to 12, they chunked it from 0 to 0.4, okay? And that's only, but you still know back's the highest, you still know elbow's the lowest, and that kind of thing. All right, so the next one, guys, I always joke about it, but it really is a good thing, is a Pareto chart. So this mathematician Pareto came up with this chart, and read what it is. It's a bar graph whose bars are drawn in decreasing order of frequency or relative frequency. So basically, you just take the exact same bar graph we had up here and go from high to low, and he was able to put his name on it. Like, I want a Molly chart, right? And why? Like, why do we need to know this? This is something that's really easy to understand and get, but it's so simple, it's easy to forget, okay? So on a test, if I ask, what's a Pareto chart? You're like, crap, there was something special. I need to know about that. Remember, the bars go from high to low. And again, you ask yourself, well, Molly, why do I care about that? Like, why can't I just use a normal bar graph? Because typically when we're collecting data, we usually are concerned with the really, really high stuff or the really, really low stuff, right? Like, for example, if we did a thing on a rehab, if we know the majority of our injuries are back injuries, we're going to make sure we have people and equipment to help them. But if a whole lot of people don't have neck injuries, then we're not going to focus on resources for that as much. Does that make sense? And if you look up here, when they're not together, it's kind of hard to tell between like what? Elbow, groin, and neck, which one's high, which one's low, because they're all kind of relatively the same height. Where when you put them in the obvious order, and this one's still kind of iffy, but if they tell you it's a Pareto chart, you know it's in the right order. So you can tell me neck is the injury that has the fewest most rehab visits. Okay, so Pareto chart, again, nothing exciting about it except for it is used quite often, and you will see that on your test, okay? So make sure you feel comfortable remembering it's high to low. All right, next one really hits everything at one time, guys. It's a side-by-side bar graph, and that's exactly what it means. It's a side-by-side bar graph, all right? So we're going to be studying the same qualitative variable, but we might look at 2 different populations or 3 different populations. And so we might have multiple bars for each qualitative variable. So on this, we wanted to study the level of education. Did people have never graduate from high school, only graduate from high school, have a little bit of college, got an associate's degree, has a bachelor's degree, or advanced degree? And instead of looking at everyone as a whole, we looked at males and females separately. So anywhere you see the light bars, it goes with males. Anywhere you see the dark bars, it goes with females. And what's great about this is it kills basically 3 birds in 1 stone. It's a graph about males, it's a graph about females, and it's a graph where you compare them. So you can ask all kinds of questions. So let's look at this first question. In general, how do male and female education levels compare? Is one obviously higher than the other as you move from left to right? Not really. Do you guys agree that every chunk, the light gray and the dark gray bar, are about the same height? Okay, so they're pretty comparable. And since they are that similar, guys, it's nice to have them right side by side. So when one does have a slight advantage, for example, not graduating high school, the males are slightly higher. Where if you had 2 separate bar graphs that were not right next to each other, it might be hard to tell which one's higher, which one's lower. All right, so that's how you can use it to compare, but then I can still ask you individual questions about males or females. So I asked you, in general, what level of education do most males have? High school diploma, right? So we're just talking about males, so we're only looking at the light gray, and I want to know most, so that's just the highest, which goes with high school diploma. All right. I like the side-by-side bar graphs. I think it's a way to kind of just cut corners and get plenty of information without having to do a whole lot. Is that all right? Okay. Let's look at the last little chart or graph that we're going to deal with. Pie chart, we've been talking about pie charts since I don't know when. A pie chart's a circle divided into sectors where each sector represents a category of the data. So each slice of the pie is the qualitative data that you gathered. The area of each sector is supposed to be proportionate to the frequency. So if a bigger slice means more people had that, a smaller slice means less people had that. The degree of each sector is found by multiplying the relative frequency by 360 degrees. We are going to do it this one time, like by hand, but you guys know that Excel can do this for you, right? Like you throw data into the Excel, you hit what chart you want, it'll do it, okay? MyMathLab, though, has you do one where you have to fill out the chart and then pick the right graph. So I just want to do it this one time so we feel familiar with it, all right? So let's look at this data. This is the same data that we got from the front page with our course, our test scores. 17%, 28%, 39%, 11%, and 6%. So I want to know when I go to draw my pie chart, what size should each of those pie slices be? And how we're going to do it is we're just going to ask ourselves, if 17% of our data got A's, then 17% of that circle should be an A slice. Well, how many degrees are in a circle? 360. So we're just going to take 0.17 times 360 degrees to figure out how many degrees this pie slice should be. Guys, since we don't have the most accurate thing, let's just round to the nearest tenth for now. And then when we go to do our chart, we'll round a little bit when we're actually drawing it. So this is, I believe, 61.2 degrees. Is that all right? So about a third, but doesn't that make sense? Or not a third, about a sixth, which we had 1/6 there. 28% of a circle is 100.8 degrees. %39 of a circle is 140.4 degrees. 11% of a circle is 39.6 degrees. And last but not least, guys, 6/100ths of a circle is 21.6 degrees. Is everybody okay with that? I know I went quickly, but I trust you can all throw that in your calculator and multiply by 360. All right, when we go to draw it, just round to the nearest 1/10 of a degree, because if you look at the circle, I have like every 90, there's 10 slots. So every little, you see very, very vague lines as we rotate. You guys kind of see those? Those are 10 degrees. So do you guys agree that 61 degrees is pretty close to 60 degrees? So just count over 6 little sectors and you can draw your A's. 1, 2, 3, 4, 5, 6. So those are my A's. And this is where you might throw in 17% or something like that, or it might be a certain color. Or if you're crafty, shade it a cool way, something like that. Do you guys agree? Does everybody see what I did? So I just went 6. All right, 100.8 is basically 100 degrees. So that's 10 sectors we're going to count. But we're going to count off of where we stopped, okay? So count 10 off of that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that will be our B's, which is about 28% of our data. And then that just continues, right? 140 degrees is 14 sectors of 10 degrees. So I'm going to count 14 off of here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I went 14. And that represents my C's. And that makes sense, guys. That was more than a third. And notice that's more than a third of our graph. It's 39%. All right. 39 degrees is basically 40 degrees, which means it's 4 more little sectors past where we stopped. 1, 2, 3, 4. And that is our D's, which was 11%. So we just went 4. And then the math kind of worked out great for us, guys. 21.6 degrees is basically 20 degrees or 2. So that's our F's. And that's 6%. Does everybody remember doing this like in 5th or 6th grade? Like when you had to do different pie charts and stuff like that. So MyMathLab, how they'll have it is they will give you most likely either the relative frequency or the frequency. If they just give you the frequency, turn it into the relative frequency, and then multiply each of those by 360 to know which chart you're kind of going with. All right? Why is this a good chart? Because you can see right there, not just with bars, but with a whole proportion. Like you have a third of your data is made up of C's, where on a bar graph it might be hard to tell that since there's A, B, C, D, F, all of those are different.